Picking up where we left off, number 5. We are looking for, we have that two-way table, and we're asking, is that claim that the likelihood of selecting from Baltimore is less than the likelihood from either of the other two cities? So what we can do is we can compare each of those likelihoods from the other two cities. Okay, but if we're selecting one teen from each sample, okay, if we're selecting one teen from each sample, we need to factor in, we can't just look at, that's the main thing on this question. We can't just look at the raw numbers and say that the 727 is less than the other two, therefore that means that it's less likely. Since we're selecting one teen from each city, then we should equalize it by using proportions and not our counts. That's the main idea on part A. And that's really all you need to say on part A. As far as hypothesis testing, they'll ask about that in a later part of the question. So that's really all you need to say on part A. On part B, construct a segmented bar chart. This is where we compare those proportions. How can we compare those proportions? Here's what your segmented bar chart should have looked like. And you can calculate those proportions. That's what it asked you to do in the next part. So there's what the proportions should have looked like. And looking at that, which one had the smallest proportion? The next part, asking which one had the smallest proportion. Well, it would be San Diego with the 0.65. And you can see that pretty clearly in the segmented bar chart that has those proportions. Then on part C, inference procedure for investigating whether there's a difference among the cities. So we have the variable, which is the proportion. That's the single variable that we're using. And we're seeing if the proportions are the same among all three. Chi-square test for homogeneity. And the null hypothesis would be that there's no difference between those proportions, and the alternative would be that there is a difference between the proportions. And that's a chi-square test for homogeneity because you're just keeping track of one variable, which is the different cities. Right? We're not comparing two different variables to each other. The yes, no could just be turned into one row, which is the proportion. Who said yes? All right, number 6. So, compare distributions. You got a box plot and you're asking to compare distributions. It's time for shape, outlier, center, spread. That's what you want to, if you're asked, if you got a box plot, if you got a dot plot, if you got histograms, and you're asked to describe a distribution or compare distributions, you should be talking about shape, outlier, center, spread. And since you're comparing, you should be using comparison words. Examples of comparison words are things like, this number is higher. This number is lower. These numbers are about the same. They're about equally spread out. They both don't have outliers. They have the same shape. If you just say the mean of A is 15 and the mean of B is 20, you have not compared them. If you said B has a higher mean than A, that's comparing. Use comparison language if you're being asked to compare. So, Newer Stadium has a higher median attendance. We're using median because that's what we have in the box plot. That's our measure of center. Then the median in the old stadium, and I cited about what each of them were. And then the newer stadium also has a higher interquartile range spread than the old stadium. We can't really get shape from a box plot because that only gives us 5 numbers of the data set. So we can't really get shape, but you should be talking about comparing center, comparing spread. That's what they're going to be looking for. So once we have compared those figures for the old stadium versus the new stadium, now we get into our scatter plots. Compare the trends. All right, now that we're describing trends in a scatter plot, the features that we want to describe in a scatter plot are strength, direction, and form. The old stadium shows a weak association. There's a lot of high amount of scattered points are all over the place. It doesn't seem to go in a positive or negative direction. Attendance did not increase much on average. On the other hand, the new stadium shows a strong positive linear association, strength, direction, form. Strong positive linear association between the two variables. Fairly sharp increase over time. So that's our comparison. Much more positive association. Now, breaking that down a little bit more, we have these two scatter plots in part C. They're identical except one labels which one's the old stadium and which one's the new stadium. Graph 1 shows the average attendance versus number of games won. Describe the relationship between the variables. Again, strength, direction, and form. Strong positive linear association between number of games won and the average attendance. Graph 2 shows graph 1, but also indicates the old and new stadiums. Does graph 2 suggest that the rate at which attendance changes as the number of games won increases is different in the new stadium compared to the old stadium? So, the rate that something goes up by, slope, rate of change. Based on the slopes of the lines of best fit that would be drawn, does not seem that the rates of attendance changed much between the stadiums. In other words, that slope of the regression line would be about the same if I drew it for just the old stadium points or just the new stadium points. The slopes wouldn't be all that much different. And then finally, part D, 3 variables, number of games won, year, and stadium. Based on these graphs, explain how one of those variables could be confounding variable between average attendance and the other variables. Remember, confounding variables is saying we don't know which one is a causing factor of the other. So what is causing attendance to increase? We could have some of them be confused with the other. And let's look at that. At the old stadium, the team generally won fewer games, whereas at the new stadium, the team generally won more games. This is where the confounding comes in, because we don't know which of the two is causing the increase in attendance. Is it because they have a fancy new stadium? Or is it just because the team is better and winning more and that increases attendance? That's why it's confounding, because we either one of them could be causing an increase in attendance and it's hard to tell the difference because both of them are happening at the same time. So that's where the confounding comes in.